7, mixture problems. First of all, let me just show an example of what this kind of problem is. I'll zoom in here so you can see it. This comes from lesson 7.7. So we're going to be doing this example, but here's the word problem that would go with it. A health food store sells a mixture of raisins and roasted nuts. So it's like a little trail mix they sell. Raisins sell for $3.50 per kilogram and nuts for $4.75 per kilogram. How many kilograms of each should be mixed to make 20 kilograms of this snack worth $4 per kilogram? Maybe they mix it up and they sell the mix for $4 per kilogram. But the separate price of each item is $3.50 for the raisins per kilogram and $4.75 for the nuts per kilogram. Well, they want to sell the mix for just $4. But they don't want to lose money if they put in too many nuts, which are more expensive, then they might lose money on this mixture, this trail mix they're selling. So again, the question, how much of each, the nuts and the raisins, should they put in if they want the total value of it coming from the value of each item separately? Okay, so first of all, we need to figure out what we're looking for. And here's the chart. I know, let me see if I can go over some of this with my pen here. This should say number of kilograms times, this is a dot for times right here, times the price per kilogram equals the cost. Now, what I'm setting up here in this chart, again, in the work I'm going to give you today, the charts will already be started, so you don't have to figure out how to set it up. The chart is how I want you to go about solving this. You're going to use this chart to solve the problem. So the first thing we're going to do is figure out what can I fill in that I know. And think about this little equation that I put up here. Now kilograms, think of it like pounds, right? A kilogram is just a little more than 2 pounds. So it'd be like how many pounds or kilograms times the price per kilogram equals the total cost of that item. Now, let's look at what we know. I know the price per kilogram of raisins. It says in the problem it was $3.50 per kilogram. It also said that the cost of the nuts was $4.75 per kilogram. So again, I start by filling out what I know. In the ones you're going to be doing, the charts are going to be almost completely empty. So this is how you start. You go, okay, let me take the information I know and figure out where it fits here. Now, take a look. If you don't have it open, you might want to get to page 321 so that I don't have to keep putting this back up here. Look at what else we know. We've got 20 kilograms and $4 per kilogram. Again, that's page 321. Where would those numbers go as you're getting to your pages? We want to use all the information in the word problem somewhere in this chart. So where would that 20 kilograms and the $4 per kilogram information go? CJ, what about one of them? Give me one of them.
$4 per kilogram.
Okay, good. Under the mixture. They want the mixture to cost, they're going to sell it maybe for $4 per kilogram. So that would go here, right? So we have raisins, nuts, mixture. Well, the mixture of $4. What about the 20? 20 kilograms. Vincent? Yeah, that's how much of it they're going to make. So we put our 20 here. Notice up here the equation shows that we're taking the first column, the number of kilograms, times the price to get the cost. So far, the only one I have all the information for is this bottom row. So let's go ahead. 20 times 4, $80. The other ones I can't do yet because guess what? I don't know how much I need. That's what I'm trying to figure out. How many kilograms of each? Now, here's the idea. We can only use one variable. I'm going to write up above here. We're going to use X for this. I don't really care what letter you use. Might as well just stick with X, but if you want to use something different, that's fine. We need to represent one of these unknowns with the X and then find a way to use that X again. I'm going to say this X is going to represent the raisins just because I have raisins first in the chart. no other real reason, is the number of kilograms of raisins. So you gotta decide, okay, which variable, what's it gonna stand for? And if it helps to write this down so that you remember, oh right, that's what I use the x for, then that's fine. Otherwise, now I go, okay, if x is the number of kilograms of raisins, well now I know what to put in this box. I still don't know the answer yet, but I know x. Can I multiply these two? Yeah, I don't know x yet, but I know this would be 350. Now I'm going to just get rid of that extra 0 just to save space. You can write 350 or 3.5 times x, and that's all I know so far. Now, let's think about what we can do for the nuts. We have to use x again. We can't use a different variable. If the total is 20 kilograms, and x of it is made of raisins, anybody have an idea what I could write for nuts? Daniel?
20 minus x.
Either he's very smart or he saw it in the book. Think about what this is, because this one, of course, is in your book, page 321 for you. The rest of them for homework won't be. If I have a total of 20, if I subtract the raisins, whatever's left over should be nuts, right? Again, total of 20, take out however many kilograms of raisins, whatever's left over. The leftover we find by subtracting the amount of raisins. Now, I'm going to need to distribute. Just like I can multiply these, this one, 475 times 20 minus x. Sorry, my box is a little small to fit all that in. Hopefully you can get it in there. Now, we got to think about how to use this. The cost of the raisins in the mix plus the cost of the nuts, D's nuts. That joke is only good for this 1 year. I got to use it. By next year, nobody will know what it is anymore. The cost of the raisin. Now, guys, here's the other thing you're going to have to do on the homework is you're going to have to be able to think about this and try to figure out how do I use this chart to solve this. If we take the cost of the raisin, so notice I'm using this final column here of cost, right? We did all these other boxes to figure out this part here that we can use. The cost of the raisins plus the cost of the nuts should equal the total cost of the mixture. Hopefully that makes sense. Let me zoom out a little bit. Fit that on. There we go. Well, now that I've come up with that wording to think about how to set this up, all I have to do is plug in the information. We have each of these already figured out. Cost of the raisins, well, I don't know the actual cost yet, but I know it's 3.5x. Plus the cost of the nuts. Now here, we are going to want to distribute. We'll get to that later. 475 times 20 minus x. To the total cost, $80. So I'm just filling in these pieces of information from the final chart. Now, let's go ahead and distribute in here. 3.5x can stay. 475 times 20, I get 95. Minus 475 times x, 475x equals 80. So now we just start solving. I distribute first. Then I start to look for like terms. My like terms are the 3.5x minus 4.75x. Think about what we would do if these were whole numbers. If it was just 3 and a negative 4, we would just do the math, 3 minus 4. And you could probably do that in your head to get negative 1. We do the same thing, except just use your calculator if you have decimals. It's 3.5x's minus 4.75. I just typed 3.5 minus 4.75. Now this will be negative. Mine doesn't show the negative very clearly there, but negative 1.25x is what I get from combining those. Does that make sense? I got that? Just taking the numbers, 3.5 minus 4.75. That's how many x's. I still have plus 95 equals 80. I know this part takes a while. You got to be careful with your decimals and your signs. There won't be too many problems for homework. I'm going to leave the x alone. I'm going to start by undoing the 95 by subtracting it. Negative 1.25x equals negative 15. And finally, to get the x by itself, remembering that this is negative, and that's okay, divide both sides by negative 1.25. And this should come out a positive number. I can't have a negative amount of raisins. That doesn't make sense. But it will come out positive, negative divided by negative. So I know I'm going to get a positive answer. I just go 15 divided by 1.25, and I get x equals 12. Now, let's finish it off. The question said, how many kilograms of each should be mixed? Well, if x equals 12, that means 12 kilograms of raisins. And how many nuts? Well, if x is 12, 20 minus 12 is 8. So we do have to add in 8 kilograms of nuts. So your final answer, I boxed the 12. That was a little early. Shouldn't have boxed it yet. X equals 12, we take that and we make sure we answer the question. Okay, 12 was my amount of raisins, 12 kilograms, 20 minus 12 to get the amount of nuts. Right.
How come in the book it says multiply both sides by multiply?
Yes, if you are looking at the book, and I'll show you here, that gets rid of the decimals. I think you guys are smart enough that you don't need that. So I skipped that, but let me show you what Brian's talking about for those of you who are looking at the book. First of all, they showed it the way I did where they got rid of that extra 0 on their 350. If there's 2 decimal places on any of these, if you multiply, now this is everything, by 100, then it gets rid of the decimals. They got the exact same answer. I think that this can be confusing because, here's why, Brian, the other reason I didn't show this step, A, you guys don't need it, you're smart enough, you can work with decimals, but also if you forget a piece, notice they multiplied the 3.5 times 100 and made it 350, they multiplied 4.75 and got 475, but they didn't multiply these, but they multiplied the 80 to get 8,000. It's real easy to forget this last piece and not multiply it, and then your whole answer gets screwed up. So if you want to do that, you can. I think working with decimals isn't so hard as long as you can remember, just use them like it would be a regular number. Okay? Let's do one more. Now, in your book, turn to 322. Again, here's the word problem that we need. And this is kind of a real situation here. So this is why we're doing these problems. I know they're a little different than what we've done, but these are things that you might actually use in life at some point. An auto mechanic has 300 milliliters of battery acid solution that is 60% acid. So this solution is 60% acid. He must add water to this solution to dilute it. Okay, otherwise it's going to eat away your car battery. So that it is only 45% acid, how much water should he add? We need it to have a percentage solution. Now again, any problem I give you like this, whether for homework or a test, I will give you this chart. I'm not going to make you make the chart yourself. So, it has the formula up here. Total amount of this solution, this liquid, times the percent of acid. So you don't have to come up with this way of figuring it out. The total amount of the solution times the percent of acid equals the amount of acid in each solution. So let's fill what we know. We've got 300 milliliters. We don't need the units right now. 300 of the original. And that is 60% acid. Let's go ahead and turn it into a decimal so that we can work with it later with our calculator. So the percent of acid, 60%, I made it into a decimal. Now it shows up here again that we're multiplying. Let's just go ahead and multiply that. 300 times 0.60, and I get 180. Now that would be 180 milliliters. of the total amount of 380, 180 of it is pure acid. It's kind of the idea there. Now, water. How much acid do you think is in water? Use your science brains. Jim? None. Otherwise, when we drank water, it would eat away our insides with every sip. Total amount of water. Well, let's have that be our variable, because that's what we want to find out, is how much water he needs to add. So I'm going to say x is the amount of water. What's x times 0? 0. Now, the new solution. There's a number we haven't used yet. In the problem, it said that we want this new solution to be 45% acid. Again, I'm going to turn that to a decimal. 45% acid, 0.45. How much is the new solution going to be in size? Well, we've got the original of the 300, and we're going to add water. So I add them. We're adding water. We use addition. And on this, again, we're going to end up needing to distribute. We're taking this binomial times 0.45. So again, I'm sorry, my box is a little small on this chart. So you might need to do like I'm doing it, right over the edge. Okay. Now again, I'm going to give you, for this one, I'm giving you, what are we going to do with this? And remember that what we're looking at, whoops, and I should have gone out here, there we go, is this final column is often what we're going to use. Now, not completely, right? I mean, not look at each problem to make sure that it fits that situation, but here's what we're looking at. We're looking at the acid amount in the original. I'm trying to not write too many words here to save you some time. The acid amount in the original plus the added acid equals the new solution amount of acid. I know it's a lot of words. If we take the acid amount of the original plus the added, now again, notice what's happening each time is we're taking this first box plus the second box equals the third box. The acid amount of the original, we already did the multiplying, so 180. In the book, they still show it as 300 times 0.6. Well, we already did that, so we have the 180 ready to go. Plus the added acid, 0. Equals, and now let's go ahead and take this. I'm going to distribute it as we go. If you guys are okay with that, I think we can go ahead and just take this 0.45, and instead of rewriting that thing, I'm just going to go ahead and do the math. 0.45 times 300 equals 135 plus 0.45 times x. Now again, your book shows it without the decimals, or they've done the times 100. We don't need to do that. I think that makes it more confusing in my opinion. Let's just start to simplify. Left side, that's easy. 180 plus 0, 180. On the right side, I cannot add these yet, so all I'm really doing here, and if you wanted to skip rewriting all this, you could. I'm just showing that the left side is simpler than the book. Now, let's think about how we solve for a variable. What do you think I'm going to recommend we do next? Luke?
Subtract 135.
Good. We leave the variable part alone. We subtract the 135 first. 180 minus 135, we get 45, equals 0.45x. I just divide both sides by 0.45, and I get 100. 100 what? Well, if we look back at the question, the x and our chart, the x is the amount of water. The question said, how much water should he add? 100 what? Well, whatever unit they're using, in this case it's milliliters, that's what it is. How much water? 100 milliliters. And that's the only unknown we need here. So,